Okay, got that phone call. Okay, so there is a difference, and I'll go over again, you guys, how to do this because I know you guys are going to be rusty. Okay, so notice the difference here, that this one has the equals. So if I just said factor this problem, you would have said, okay, I need two numbers that multiply to 8 and add up to 6. 4 and 2. So we would have written x plus 4, x plus 2. And I would have stopped right there because there's nothing else I can do with it. Whereas this one, I would have gone x plus 4 times x plus 2 equals 0. And then I would have said x is either -4 or -2. And I'm going to go over this again. So don't worry about like, wait, how did you know how to do that? Don't worry, I'll go through that. But this is just trying to remind you that if there's no equal sign, you stop. That's all you can do. That's your answer to that problem if it just said factor. If there is an equal sign, that's where you get answers. Okay, so let's look at how do we put all this factoring together. And in Math 3, every year the students are very confused because it's a lot of material. Okay, so I want you to kind of run through this list through your head every time you go to factor a problem. You should be thinking about this every single time. So the first thing you're going to do is you're going to look for a GCF, no matter what. Every single problem, I guarantee you when you're stuck and you can't get something factored, it's usually because you forgot to do this one. Okay, so factor out that GCF. Okay, the next thing you do is you look at the number of terms. That's going to help you determine what method you should use for factoring. Okay, so if there are 2 terms, it's got to be either just a greatest common factor problem or the difference of squares. Notice difference here. It's a minus sign. The difference of cubes or the sum of cubes. Okay, and I'm going to go through each of these types with you, so don't worry that, oh, what is she talking about? Okay, now if there's 3 terms, you're going to have to decide, is it an easy diamond problem? And again, I'll go back over that. That means it has a leading coefficient of 1. Your teacher might have called it something different. Or do you have to have the AC method where the leading coefficient is not 1? And then the last thing that you want to do or look for is if there's 4 terms. And if there's 4 terms, you're going to try factor by grouping. Now, good practice here, never ever factor the problem if the leading coefficient is negative. Very important. And again, I'm going to go over that with you guys. Okay, so let's just get started. So that's our general overview for when we get going and we have a whole bunch of problems that are all mixed together. Okay, so let's look at the basics. So you could just have factor out the GCF. Okay, so I look at 12 and 18. The biggest number that'll go into both of those is 6. Okay, they both have an x and they both have a y. Notice I didn't put 6xy up here. Okay, now I'm thinking 6xy times what will give me 12xy squared? Well, a 2 and a y. Bring down that plus. And I'm just thinking 6 times 3 will give me 18xy. There it is. Okay, over here, they both have a 5a. Now, I want you to be careful with a problem like this. This is another one I see a lot of mistakes. So I know that 5 times 5 will give me 25, and a times a squared will give me a cubed, and then I need a b. And a lot of times I'll see students just leave it like that. You have to make sure that you get this back again. So 5a times what will give me 5a? That's a 1. Okay, so I want you to watch out for this problem because I see that a lot where students forget that. Okay, difference of squares. So difference of squares you guys learned. Again, it could have been a whole year ago that you learned this. And it said, okay, if you have 2 numbers, a squared minus b squared, that are squares, you go a minus b, a plus b. And it doesn't matter which order you put those in. Okay, so x squared, that's a perfect square, that's a perfect square. Do not put square root symbols on those, okay? You're just going to write x minus 5, x plus 5. We can't solve, there's no equal sign, done. Okay, here I'm checking there is no greatest common factor. I can take the square root of both of these. I know the square root of 3x squared, or excuse me, 9x squared is 3x. The square root of that is 4y. So 3x minus 4y, 3x plus 4y. And remember, it doesn't matter if you put the plus first and then the minus. Okay, so that's it. Now, let's look at ones that I want you to be careful about. So a lot of students just switch that around and they write x squared minus 36. That is a different problem. Okay, so even though the x squared is second, it doesn't matter. You're going to go, this is 6 minus x times 6 plus x. Okay, don't flip that around. All right, let's look here. Now, I'm looking here going, wait, those aren't perfect squares. That's reminding me there must be a greatest common factor. So what do both of these guys have in common? Let's try to take out the 2, and it looks like they also have an x in common. So I'm going to take out the 2x, and I'm going to be left with 2 times 25, x squared will give me 50x cubed. 2 times 9, y squared will give me 18xy squared. Now, just like when we were here on this problem, and we had to keep on going, we have to keep on going. That is the difference of squares. So don't forget to bring this 2x down, and then we get 5x minus 3y, 5x plus 3y. So what this means, just like this, that if I did 2 squared times 5, I would get 20 back again. If I did this times this times this, I would get that back again. That's what it means to factor. It just looks different, but it's the same thing as what we were doing here. I should say the same concept. Okay, now be careful about the sum of squares. People want to tell me that it's a plus b, a plus b. Well, let's check. A times a is a squared. A times b is plus ab. B times a, I'm always going to write it in alphabetical order, is ab, and b times b is b squared. Let's see. That gives me 2 ab's. That is not it. Then I'll have students go, oh, then it must be a minus b times a minus b. No, not going to work either. This is prime. Just like we know when we did this, that the number 5 was prime. We couldn't factor it any further. Okay, that's it. So watch out for the sum of squares. You cannot factor that. Okay?